Hello and welcome back. I'm sure you enjoyed that stretch or whatever you wanted to do and have a something to have a bite and got the energy flowing back. Okay, we left it here and I'll start from here. So I opened the IDE and I went to File, New STM32 project, and this is the window it will open. Here you have to select board selector, and you got to, if you know the part already, that I know because I'm using the board Nucleo F411RE. So you just type in there in the search in the commercial part number, and there it is. Just select that and then click on next. And we need to give a project name. So today we are on day 14 and we are learning UART transmit, so I will resemble that. Day 14 underscore use transmit. So we're learning about transmit, and since we are learning from scratch, you have to select, I have to select to teach you today as an empty project, targeted project type. And if you also want to start any coding from scratch, this is what you got to set as an empty, and then hit finish. This will start to generate the project tree and it will get all the necessary files linked to it here. So as you can see, day 14 is there. I will just minimize all of the other ones that we don't need of. So day 14 there. I'll close all the previous files so you won't get confused. Okay, so we have to go to the source. We have to go to the main program. And as you know, anything that's on the green is comment, basically, with slash star and finish with star asterisk and slash, and that's in comment. So it's to say what file name it is and who has written that and which part of this program in terms of the whole programming body. And you can leave the, and you can leave the microelectronics and a bit of license version in there if you want. Since we're learning from scratch, I will delete all the internal programs not to confuse you, so I'll leave just that. Okay, first we learned about how we need all the bus information and the peripheral information. When we talk about bus and peripheral information, everything controls and controlled by registers, and those registers being programmed to the address of that particular register. So in embedded C programming, those addresses are the must. So you need to go into details of every special function registers and look for that address, copy and bring it here because you're going to use it, and I'm going to show you how. So just before doing that, I'm going to compile this program so that the .elf file will be generated. So I'm going right click, build the project. And this is to do the initial setup. So when you want to debug, it will start to debug to your target board. So that's what the basic steps are. First, you have to generate the .elf file that you learned previously. It stands for, executable link format file. Good. It's building 98%, so 0 errors, 0 warnings. So that means it has what already generated elf file. So I'm going to do the debug option settings. Click debug as and go to debug configurations. This is to set up your target hardware, and you have to select which project you are working on, so that particular .elf file will be linked to that project, otherwise you'll get plenty of errors. So make sure you double click on this STM32C application. When you do the double click, and if you have already created the program tree, the project tree, that will go directly to that into the debug mode. So this name comes through. Make sure the debug, this reference path is set to .elf. If not, then you will get another error as well. So make sure you know how to get there by click on search project and browse, all of that. So the basic two things that you have to do is inside the debugger tab, you have to click which interface you are going to do. in this case we are targeting on Nucleo F411 ST-Link. It's a ST microelectronics board, so you need to enable that programmer. So the STM32 has a built-in programmer. That's what used for debugger. So you need to enable that in order to debug. That's basically it. So you need to enable that. On the serial wire viewer where you want to see the output, so click on enable and then hit apply and then click debug. This will generally start to change your perspective from it will say asking for permission, from C++ perspective to debug perspective. So that's the these two steps we got to do. So it came as not detected, so I'll do debug because I just set the configuration. This time I'll go to STM32 application. This will start to pile up and will change from the C++ mode to debug mode. It's on 79% if you would see here. And once it changes, then we can go into the special function registers and we can look for the registers that we need and those addresses. Okay, today we are dealing with STM32F411. So we got to go here and copy all the addresses that we need to use it in our program. As you know, the first step is you need to enable the reset counter clock to tell which port you're going to use. So you need to enable the clock for that. Where that will live? That will live under RCC register. So you need to elaborate that. And you have to enable AHB1ENR. First, let's go through all the special function registers and copy the addresses and put it here for easy access, and then I'll take you through to the program. So you need to copy that address. So the first one is you got to enable port A, that is the GPIO A. For that you need this register RCC AHB1 ENR, and its address is, you need to use this address letter, so you got to copy this and keep it here for our reference. So okay, what is the next step we need? I'll copy this because all we need is just the register. So I'll copy so now we have to enable the peripheral bus, the advanced peripheral bus, meaning you need to enable the clock. Sorry, enable peripheral bus. Enable peripheral bus, spelling peripheral bus. Okay, and where will that be? Again, it will be in the reset counter clock RCC, and you have to look for APB1ENR. So APB1ENR, so that's the one you want, peripheral enable. So you want this address, APB1ENR. You need the whole address, so copy this and paste it here so you can use it for the further reference. So the next one is APB1ENR. Okay, so now we need to set the port A mode, the port A2, into alternate function. So to do that, you have to set couple of registers. So I'll just copy that. Now set, this is just for reference, so you don't have to type all of this. I'm just copying all the addresses, so it will be useful for us to program later. So set port A for alternate function And where will this live? Where will these registers be? You have to go to GPIO registers. So we are using GPIO A register, GPIO A. So we are going to use as the port modder. The port modder is the one where you're saying what type of mode you're going to use. So this is where you need to set that as a transmit mode. So it's inside GPIO A, and first you need to use is your modder register. You can call it as, for naming convention, be much easier, GPIO A modder, and then copy that address 040002, that address, copy that and replace with this. Now we need to say the alternate function, whether is it your low register or high register. So you got to say that. So now the next step is to set that AFR, set port AFR alternate function type, what type it is. So where will that be? It will be on AFR low, alternate function register low. So you need this because we doing data transmit today, use RTX, and that's connected to port A pin 2. And if you see the table 9 alternate function mapping, and if you see that it's using alternate function 07, and any pin that you want to interface between 0 to 7, then you need to use AFR low. Or if you want to use pins from 8 to 15, you got to use pins from 8 to 15 as high, AFR high. In our case, we're going to go for AFR L. So we need to type that. It will be under GPIO GPIO A AFRL, and then copy this address 0 cross 400. Yeah, copy that and replace to this. Okay, so now we let the alternate function type and alternate function to use that same pin. Now we need to go and configure the USART. So for that you need to go and set now configure USART module. And where will the USART module will be? You need to look for USART2, which will be under peripherals, not peripherals. So it will be inside STM32F411. So there is separate peripherals session to it. So we are going to use USART2. So it will be in USART2, and we're going to use, we need status register, we need data register, and the baud rate, and the control register one. I'll explain to you when we write programs. So we need all these four, basically all the four USARTs. So I'll start with USART2 USART2 underscore status register first, status register. And what's the address of status register? Double click. The status register address is this one. So come here and replace that 4400. Oops, sorry, not there. What am I doing? Sorry. type GPO. Okay, here it will be on usart2, which will be on usart2. You need the status register, and the address is this one, 4400. So likewise, you need the data register, and also you need baud register, you need the control register. So you need control C, data register, baud register, and CR1. So we are still configuring the usart mode. So we need, next one is data register, which is this one, because this is where you're going to save the data to communicate, and you're going to transfer it. So everything has to, all your data will be sitting inside this register, and you're going to use this register to communicate. So that's why you need a data register. Okay, 4404. The next one is baud rate register generator. So that's the address for baud rate. Control C, come here and change that to V. And this will be baud rate register. And then the last one is control register 1. We're going to use control register 1. So you need that control register, and that's the address you need. Control C. Okay, so it is a very good practice. So once you know which register and which bus and which peripherals, it's all linking and going to interface with your microcontroller, then the good easy way is coming here, going to window, show view, and if you click on SFRs, and this is what you get, and you go and get all the registers that you're going to program with, and you're going to write program to locate to the address. So that's really key. So now we did the easy bit. So now we'll start to declare all this in a pointer variable so that it can be used in the main program. So the next step is you're going to declare all of that into a pointer mode. So to start off that, pointer mode, yeah. Let's switch. As you see, address. Okay, we did copy the address. Okay, now we need to configure the pointer. So to do that, this is where this will be really handy. We are inside the include. So you got to do this, and the pointers will be specified with a small p. So that means it's a pointer, and you got to define all the pointers with all the label names, and then you got to typecast this, and link that with the addresses. Control C. So this is the first one we are declaring. So I just copy that. You got to do that 8 times. So you need 8 of these. Control C. For good practice, if you don't confused, you can type in line by line, which would make your life a lot easier, because if something goes wrong, then you know which line you typed and where you want to go and change, so which is always really handy. So the second one is we're going to set this pointer APB1ENR. So copy that, come here and paste it, and then the address for that is this one. See how much easier it is, because you already went and checked all the registers that you need, and you copy that address, and you just come here and write one line, and you can this is how you can do if you want to do fast coding. So this really helps, but this will come with practice. Don't get panic if you are not up to speed. Just go as fast as you can and try to learn slowly. So slow and steady always wins the race. Okay, so the next one is the modder. We're going to use the port mode register. So for that you need to copy the port A modder, copy this and replace it here, GPIOA modder, and the address will be this one, for Control C, and the address will be this, Control V. Okay, that's done. So next one is you need to set that alternate function, whether it's a low or a high register, Control V, and then you got to copy the same that belongs to the same address there, Control C, you come here and Control V it. And then next one, you're going to set the status register and data register and all the, you're starting to configure the USART now. So you got to set first USART status register. USART status register, and its address is this one. So copy this address and come here and leave it here in this address. And then the next one is USART data register. Copy this data register name, Control C, and you got Control V, and its register is this value address, Control C, come here and replace with this 4404. And the next one is USART baud rate register, and its address is going to be 4408, ending with 4408. Okay, oops, sorry, I did it wrong. Sorry, you must be telling me, hey, stop doing that, you're doing it to the wrong address copy. See, this is what happens if you want to copy. Okay, now we need to declare the control1 pointer control status. So for that you need another declaration. So copy the control my mouse, Control C, and you're going to use that here to paste, and then the corresponding address copy and paste it here. That's good. So you did the pointer declaration, so all the registers are linked to the corresponding address, and it's all pointer and it's all typecast and all good to go. So the next step in the writing programming will be, you got to write the main program, because you declared that and you got to include all of the function inside declare into the main function. So first we need to initialize all the UART registers. So for that you got to use you can use USART init. And then to transmit and set data, you can you got to install that inside. You're calling the function basically. Then you got to write the function for the initialization. So make sure the register name, the function name, it's the same, otherwise it will throw an error. So init then that's a function declaration. Now you writing the function, what's inside that function is user init of open bracket and close bracket. So this is where you're going to tell initialize all the USART initialization. So first step is to enable the clock for GPIOA, because that's the port you're going to use. To enable that, you need to use this register, pointer register, Control C, come here, Control V, and you know that's the RCC clock. So if you remember, if you go back to the port modder in your reference manual, I'll write as GPIO so I can show you GPIO output modder, GPIO output register, output type. So for the port mode, you got to mention which port, because as you know, the 32, it's a 32-bit, and you got to write this modder 2 as USART2 transmit. So you got to use PA0, PA1, that's PA2, and you got to use bit 5 and bit 4 to say which port you are using. So that's the next step. So to do that, you need to enable the clock first and then set the port mode. Sorry, you got to enable the clock first by going there. Enable is just R-ing with yes, R, and yes, enabling that port. Let's enable. So save that. I'll show you step-by-step instructions. So this one lives inside the HB1 ENR. As you can see, now the bit is 00. You got to enable that. So to do that, I saved it. I'm going to terminate and relaunch just to see that enable program work. It's doing the debug, and once it changes, it will. I'll go into step into instruction and I'll show you how that bit will be enabled. Proceed with launch. Yes, proceed. Okay, it's all going to show all this error because U in 32 from incompatible mode USART CR1 initialization of int. Because we haven't written for the whole program, it's throwing assembly error. Okay, unknown type name, PAB HB1 ENR. It shouldn't throw error. I don't know why it's giving. Going to step. Okay, might have done. What did I do wrong? Include standard input. Int main. You're using int. You're using the declaration. That is all looking good. It should come as okay. Enable. Okay, maybe let's declare all of that being an unsigned value. So build first to get all the error. 9 errors. give me one sec, guys. I'm just trying to see why it shouldn't show any error at this stage, but it's showing some error. I'm just checking with my written notes, which I have written earlier. And terminate and relaunch, then you go for the second step, int main. So you written that, you copied all of that int, all of that type constants. phb1 then you're r'ing that with enabling that. So I'll try again, change to debug mode. Let's see, debug mode, building project. Nine errors. Sorry guys, did you pick that up? I'm really sorry, it's my bad. That's why it doesn't. So the ID is really cool. So if you see any red line underneath, that means you have made a typo error, meaning when you typed, you might have hit a wrong key and that changed. And this is one good example, because what I did was copy and made it as 8 different copy and paste, and look what happened. So this is not a good practice of writing code, but I want to explain that in a fast fashion. So I did that, but I know what I did wrong. So see, the pointer declaration, so this doesn't know, the compiler doesn't know what type it is, because I made a simple typing error. Instead of uint, undefined int, and I typed as unit. Because I copied 8 times, it's throwing that 8 warnings followed by link error. So sorry, so I got to go and fix it, which I'll show. It's uint and uint, not unit, uint. Even the color change will get you the clues, but to be honest, I didn't check the exactly before compiling. We are all learning, so that's my excuse. uint 32, uint 32, uint under 32 underscore t, so that will reflect on this. So what else it's showing? Unknown type name. Yes, did you mean yes, that one? Okay. So now if I go to the correct project and build, this should build now, because I rectified the error. A simple mistake, but yeah, please, when you type, please make sure that you type that particular line, and then make sure it takes with a lot of practice, but it's good that it's happening when I'm teaching. So I'm here to rectify that fault, and I can show you, like, if you face these sort of problems, then you know what to do and what to do for. So this is also a good debugging skill that I'm developing for you as well. So this is what you will face in the real-time analysis. So if you're writing a code, and you will see all this error happen, so don't panic, come to my videos and there is a solution. So you go there and check for yourself, and you can fix it. Okay, so that's happy. So I'm going to set to debug mode, and I know we set the declaration early, but I'm just double checking to make sure it's targeted to the link. Okay, apply and debug. This will change from, this is to show you to enable the clock for the RCC module. It's changing from CC perspective to debug. Once it's done, I'll show you step into execution, and I'll show you how the bit is enabled, how the clock is enabled. Okay, it's asking to switch. Yes, switch. we're dealing with STM32, so we don't need to worry for now. Cortex M4, so that's downloaded. So now if I go and keep this open, and you please watch this AHB1 ENR, just this value. When I go to step into, it goes directly there, and see, now the clock is enabled. Before it was 0 cross 0, now it's enabled. So you're doing the right thing by checking whenever. As a learner now you can check, because when you write about 200 lines of code or 500,000 lines of code, then the debugging will be really hard, because you need to go each and every line. Well, the breakpoints will come in handy and the watch points will come in handy, but still you need to consume a lot of time to fix it. So as a matter of rule, the learning coding stage, when you try to change the bits, try to match that with the register. Go into the register and see, by going into step into run, instead of full run, full resume, go into step into, and if you click that, then you will see for yourself whether you made that bit to 0 or 1. So we asked the bit to 1, so that's what it's showing, enabling the clock. Okay, now the second step is, what is it? It is enabling the peripheral bus clock. Enable the clock for user 2, because that's connected to the peripheral bus, which is this pointer register that we declared earlier. So we're going to set that as to, again, simple R. You need to enable this undefined 1U, and you need to shift 17 times. I'll tell you why 17 times. Just one sec. So save for now. So you're trying to enable this. So go back to the register. So this is, as you know, you are setting to USART2 and you're using port A pin 2. So this is port A pin 2. You already set the GPIO model. So now you asking the APBI in the RCC. So we are in GPIO. So I'll go to the easy way. Also you can click that, and then you can go directly to RCC files if you can see RCC in here. If not, then yeah, reset and clock control. So if you go there and expand RCC registers, so this is where RCC register starts from 99. So why load, still downloading. Okay, further down, so we need RCC APB1. So RCC APB1, that's a peripheral reset. Oh, sorry, that's a, yeah, that's a peripheral reset. So that's on by after it downloads. Okay, so this is the register. We don't need the reset register. We need AHB1 RCC underscore RCC underscore APB1R, which is, go back, click the index. This is inside the reference manual, the STM32 reference manual. You have to go to RCC register, and we are after RCC APB1, RCC APB1 ENR. So that's the HB1 ENR. We need APB1 ENR at 6311. This is the register we are after, RCC APB1 ENR. And as you know, by this register, the USART2 we're going to interface with, it's on pin 17, so bit 17. So that's why you need to do 17 shifts to the left to get to there to enable this pin. So that's how you have to write the program. So that's this step. So I'll just terminate and relaunch, and I'll show you the bit value change here. Okay, still doing conversion from C++ perspective to debug perspective, so I got to wait. We got to wait until it changes, and I'll show you the bit change. Yeah, switch. So as we already enabled the clock for the GPIO port A, that's enabled. So now I'm going to go into showing both enabling the advanced high performance bus clock and the advanced peripheral bus 1 clock. So those two has to be enabled first, because we are learning USART, and USART works with clock signal. So the data transfer syncs with the clock. So that's why you need to do these two steps first. Okay, we are in debug mode. I'm going to click step into, and it will come to first stop at port A clock enable. Going further, step 1, see that bit as enabled. So the next one will be this port bus. Step into, watch APB1. It got the address location, the value, and now it's going to change. Step into, step into, why you are not changing? Come on, change APB1ENR. Zero cross 2000, so 30, 3840, 3840. Need to stop and relaunch. Maybe hasn't gone through the second step. Just one sec, I got to show you base address. Okay, still waiting to be debugged. And also when you do the debug, you can also see the I was about to capture the LED status, but yeah, okay, never mind. So now AHB1, so going to step into APB1ENR, AHB1ENR, and this should change AHB1ENR, it updated 01. So the next one should go as well to APB1ENR, 0th bit, so you what did I do wrong? I think I did the port declaration as 17. Yeah, 1U17 should be 1. Terminate and relaunch, step into USART in it, PAB1ENR. It's getting the value of it, but it's not showing the allocation. So one sec. Oh, sorry. My bad. Sorry, okay, APB1ENR, it got the general value, but we are only toggling the bit on 17th bit, so which is this bit. See, that's enabled. USART enabled. So we are going to enable the clock on the USART2, so this is the bit. I was looking at this address, sorry, my bad. Okay, likewise, you can also see which bit has enabled. So AHB1ENR, so GPIO enable, so that's 2. That's the one, GPIO enable 01 port 2 0 cross 1. So now the clock is finished. I'm sure you all waiting to get a bit of a break, so I'll give you a short break, so please go and enjoy that break, and when you come back I will show you further along. So